finding it. I don't know. Welcome back, algebrists. Today, we're jumping in right with this. We just did a little review briefly of the complex, or the imaginary unit I is what we call it. When we're looking at this, we are simply adding. Now, this is where I'm concerned about people making mistakes, because if you're not careful, you're going to forget to do what with that? Distribute. Cool. So, this first set of parentheses, do they really do anything for me? Like there's nothing to multiply by here or anything like that, right? So we'll just take them off. 2 minus 5i. When I distribute this negative, what do I get? Minus 3, I think. Do you see why it's negative, Sebastian? Yeah. And how about negative 1 times 4i? Minus 4i. Now, this is, if you distribute the negative, you're going to avoid all mistakes. Treat everything as if they are just like terms. So I'm going to rearrange this physically, but not everybody would. I'm going to do 2 minus 3. And then I have a negative 5i minus 4i. Many of you are going to do this just in your heads without having to do a whole lot of extra thought. I'm okay with that. What's 2 minus 3? Negative 1. And what's negative 5i minus 4i? Negative 9i. Minus 9i. And look at that. We're done. It is that easy. Okay. Do we want another one like this, or do you want to bump it up a little bit? Bump it up. Cool. One more. Okay, so this one, let's see here. On B, I want 3 plus 2i minus, nope, we're not going to get too crazy.
Wait, is there a reason why you always call it minus?
Nope, I'll even change it to plus. No, you're good. I'll change it to plus. 3 plus 2i, there's our first complex number, plus 4 plus 3i. There's our second complex number. Like terms is all we have to worry about. Now, when we look at this one, and I'm thinking, or I'm hoping at least, you guys are about done with it. Real parts. Hawaii. What do we get with the real part and the real part? 7. 3 plus 4 is 7. Good. And what about the imaginary part, Kennedy? Plus 5 what? I. Boom. Piece of cake, right? Like they look ugly, treat it just like it's X. There's nothing different except for we know that there's some other goofy stuff hanging around underneath the I here. All right. We are going to look at one more operation, rather kind of 2 more operations, but we'll work into it. Those of you that are going to be leaving here in just a moment, we will work the same examples when the sophomores are out. So if you want to get it started, we can. We've done basic operations. We saw addition, subtraction, pretty chill. What's the next easiest operation? Multiplication. So let's see here. I'm going to try to be consistent with how I label stuff. I just want to see how I did it. Is this a dash? Imaginary unit. Dash is addition and subtraction. So here we go. A new dash with multiplication. Now, for multiplication stuff, this is where it's really going to kick in. When we look at the powers of I, we never, never, never want anything bigger than I to the first power. Okay. Juniors, it seems as though it is your time to ascend. Cool. Cool, 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 cool. All right, just a cool kid, stay here. Do you guys know what's red and smells like green paint?
Green paint? Oh, wait, red paint.
It's red paint. It's red paint. Why do you guys keep making faces at each other and chuckling?
No, I can never hang out with this guy. This guy always. I can never hang out with him. That's why you have to move back.
Okay. I'm going to give you guys a challenge, and they're going to get the same challenge. Here's what I want us to do. I don't know why he was lagging behind so much, but I'm just going to write this out much like we did before, and I want you guys to help me think about what would happen. If you know what, we're just going to do a real number. We're going to do a true example. I'm going to leave a little bit of space here. And then you guys are going to give me the rule with what we think happens. So check it out. We're just going to say multiply, and I'll just say mult. And let's just jump right in. What's your favorite complex number, Ronaldo? plus or minus what?
Plus 5.
3 plus 5i. Now, I'm going to multiply this by 2 minus 6i. And I want, before we commit to this, just go with your intuition. It looks ugly with I, but it doesn't need to be any different, right? Anybody have a gut feeling what you want to do here? What? So when you say simplify, what do you mean by that?
The circle thing before.
So we'll get there, because those are both I to the first power right now. But before I see something that I need to simplify, we got to do what? Let's expand it. I'm going to write the rule right here. It's super easy. There's two words. This one, since it's a binomial by a binomial, we could use a very specific word, but I'm just going to say just distribute. The word that I was looking for, and I think Julia might have said it, but I could have heard wrong, we just FOIL. That's all we do here. Was it you? Amy, nice job. Okay, I want you guys to go ahead and try this. FOIL it out. I'll give you a minute. I'm going to close the door because it's going to be chaotic over there. Okay, for the first one, we just FOIL, right?
Oh, wait. It was offered you could reject, but if you would like to be part of it, because you're the advisor, right?
Are other teachers getting in with their classes?
Well, so far this is the first one. I'm going to try to maybe add.
Okay.
Miss Allie offered, because she doesn't have a class either.
Okay, yeah. I'm fine with that. I'll come take a picture. Sure. Okay, when I FOIL this, do you guys get a 6?
Yes.
Okay, what's this one? Negative 18i. This one? 10i, and then here's the big moment of truth. This one right here. Negative 30i squared. Now this little piece on our next little section, we are just going to replace I squared right here with a what value? Negative 1. So when we look at this, we have 6 minus 18i plus 10i minus 30 times negative 1 because I squared is negative 1. What happens with this term? It becomes a positive, right? Those of you that are not doing this, you can hold off 1 second. I'll catch up with you. So I'm just going to combine the I terms first, or the real terms. This becomes 6 plus 30, right? What's 6 plus 30? 36. And then how many I terms do we have? If we have negative 18 plus 10? Negative 8i, and we done. Okay, the place to make a mistake in this problem, it's going to happen with this I squared part. That is the one place that I'm expecting mistakes, but if we think about it like going into it, we can avoid it. Cool. All right. For this, we are going to jump. We'll do as a class this whole one. What time's the next one? Oh, we got lots of time. All right. So as people start coming back in, I'm just going to give a quick rundown. With multiplication, super easy. We just FOIL. That's it. Now, if you want to leave off this example, we can do this here in a minute. But let's work B as a whole class here. Okay. B looks a little bit nicer, and whether you realize it or not, it is insanely nice. And my hope is that over 1 or 2 or 3 examples, we'll never have to spend much time on these ever. Okay. When we're just multiplying out, and do everybody who came back just now, do you need a quick moment? Yep. Okay, we're going to pause. So the question came up, would you rather use square root of negative 1 or I? Definitely I. It's easier to write, it's simpler, it makes stuff look gross, or it looks less gross rather. Okay, this one, together, or do you guys want to try a FOIL on your own and see what some handy shakeout? Okay, multiply this. If you are done with B already, or if you need help multiplying this, let me know. I'm going to put another one, up here, just so that we have a couple different examples. So I'm going to try, we'll try a different number. Let's do 3 minus I and 3 plus I. I want us to do B and C. We're just FOILing. I will give you guys a moment. Don't just wait for me to have the answer. If you have no idea what I mean by just FOILing, let me know. We need to clear it up because we're going to be doing it all year long.
So this one, are you're doing the addition? Okay. So when we're looking at these, this one is a plus. Notice that we just had on one power. So you just take the real part. And this is the real part. And I know that because there's no I. That's the only reason I know that. So let's just combine the real parts. 2 plus 2. Yeah. Now let's
Where are we at? Okay, if you are done with B and C, couple things. You should only get a real number. There should not be an I in your answer anymore on B or C. If you've gotten there, awesome. What I want you to do is check with your neighbors. See if there's a shortcut that we could use to not have to foil specifically problems like B and C. So are you okay with how we have this? Okay. So let's combine that. Let's combine it like this. First of all, check. We have to unlock that. What's Yep, so when you see me do that on that. Try this one. Do you see a shortcut? 36. For these, not yet. Okay. All right. Checking it out. There is a shortcut, and I'm going to help us see it if you don't see it yet. Anybody think they see it? Okay. So, just foiling. Let's go first. 2 times 2. 4. 2 times negative 3i. Negative 6 what? I. If you gave me 5, I get it, but you're adding. These are multiplying. Okay. Inside terms. 3i times 2. Plus 6i. And 3i times negative 3i. Negative 9i squared. Okay. This type of expression should look kind of familiar. If you recall seeing difference of squares, which we stressed a lot, and it might not be super on the tip of your tongue. Sophomores, peace out. I'll have the shortcut on the board for you still. Okay, when we look at these, what happens with these middle terms? They're gone, right? So real quickly, I just want to pause so we can start trying to get this shortcut. How do you go from a 2 to a 4? And there's a few ways you can do this. 2 to 4, you can multiply by 2, but is it the same as squaring? Okay, here, we'll go one more step. What am I going to replace this I squared with? So, and I'll write it out in a 2-line step with the understanding that you might not. This becomes 4 minus 9 times negative 1. What happens right here? Good. It turns into a positive, so this becomes 4 plus 9, which is just 13, right? Now, I'm going to show that next step. This is 4 plus 9 equals 13. Now, it is my hope that when we move forward after these two examples, you never have to foil something that's exactly like this or this, again, because there's a handy shortcut. Looking at it, if you take 2 squared, you get 4. What's 3 squared? 9. Look at that. Those numbers showed up exactly in here. We have a way to save a ton of time on these. Now, we will refine this, and we'll make sure that this rule exists and it's clearly written down somewhere. But let's try it for the next one, just in our heads first, and then we'll see if we indeed get the right thing. If I look at these, is this 3 minus and 3 plus just like the previous? Yeah. Okay, these have a name. We'll talk about that here in a minute. What's the first number? 3. So if I think of 3 squared, somebody said 9, I'll take it. What's the number in front of I?
Negative 1.
1. Now it's negative in this one, or positive here, but what's 1 squared?
1.
I think that we should get 3 squared plus 1 squared. I think we should get 10. That's what I'm hoping for. Yeah. I want you guys, if you haven't yet, foil it out for me. Some of you already have. verify that we get 10, I'm going to work slightly behind you.
So we get 10?
I think so. Do you get 10?
Yeah.
I'm pretty sure I'm about to. So first little thing, I noticed that happens. If I minus I squared, is anybody opposed to me immediately changing that to plus 1? Why can't I do that? Why am I allowed to? Minus a negative 1. Yeah. Okay, we do indeed get 10. Now, what we're seeing here is a really important idea that we're going to ultimately use to help us with division. It'll help to solve the quadratic formula when we get to that here in a couple days. But there is a handy shortcut living here. Now, we will refine and define that shortcut for ourselves. But before we move on, any questions about this distribution or where any of these values come from?
So the exponent will always equal 1.
The exponent will always equal 1. Where are you looking at the exponent? Are you looking at this spot?
Yeah.
So if you have I squared, it's always going to be replaced with a negative 1 every time.
Okay.
Yep, cool. All right, now what we're really seeing here on B and C specifically, A didn't work out the same, right? Like we had an I in our answer and it happens, but B and C are special. We're going to define these, and this is our last little section, and then I'm going to give you guys time to work on these because I know it's like new and strange. We're going to define for ourselves underneath what we call the complex conjugate. Now, bless you. I don't feel that this is like super duper clever, but just so you know, I'm silly and I get a kick out of this every time. If we're talking complex conjugate, here's how I would typically write it. Little clever, conjugate with the C written with a blackboard C, meaning what? Complex. So look at that. It's already complex and conjugate. Now, these things, we're going to use them for division, but a quick, easy way to define the complex conjugate is just simply given two complex numbers, given two complex numbers. So have to have two of them, Angel. We have the same real part. Sorry. They have. I can't write right now. They have, sorry. The same real part. But opposite imaginary parts. Okay. If you give me two complex numbers that have the same real part, like, I don't know if, and I'm going to point to the screen instead here, like these, do we have the same real part here and here? 2 and 2, that's the same. And then the imaginary part, one was positive and one was negative, but they're the same number, just opposite signs. Then we have exactly what are called our complex conjugates. Now, same thing happened here, 3 and 3 and negative 1 and 1. We have the same numbers, just opposite on the imaginary part. Now, with these complex conjugates, there is something crazy handy that works out. We saw in the last two examples that if we want to look at a number, some complex number here or here times its conjugate, something handy happens. We're going to write out our shortcut right here in hopes of never having to FOIL if you use a conjugate again. So check it out. If we have some number, a plus bi. First thing, what's another complex number that has the same real part but an opposite imaginary part? It's conjugate, if you will. A minus bi. If you take some complex number, a plus bi, and its conjugate, which just changes the sign between them, we get something awesome. Now, I'm going to say in pink, you don't need to write it unless you want to. We have one real line that we need, but I just want to make sure everybody can see where this comes from. I want help foiling this out, and it's going to get ugly for just 1 second, but literally just 1 second. A times a. Okay, and then a times negative bi. So negative abi. This one? So it could be bia. Can I write abi? So that, like, because they have the same three numbers multiplied together, That's okay. They're going to fall out. This last one's the hardest one to write. How would you write bi times negative bi? So if we do it like this, I'm fine with it. Notice, if you do it without parentheses, does it say the same thing? I don't think so. Because right now, what is a square connected to? B and I, right? It's b squared and I squared. But if I don't have the parentheses and I just do this, what is the square connected to now? Just the I, no longer the b. It is important that we have that. Okay, these terms are gone. Now, let's go one more step, and there's only 2 more lines that we could possibly need. This is minus. What's bi times bi? So you're right, but could I expand it? Could I say that's b squared I squared? Or, and I'm going to do a little bit up here because I couldn't tell if you guys clicked with that. bi times bi, I can rearrange these, right? Multiplication is commutative. I'm just going to commit to it. B squared I squared. Anything that we can change here? Only this part right here. What did you say, Angel? I didn't catch it. The squares, and specifically this one, because what is this square? So we could get a squared minus b squared times negative 1, because I squared is always negative 1. And anything convenient happen here? A squared minus a negative b squared? It's just plus, right? B squared. This is the shortcut, and we'll scroll back up. All this pink stuff is just the exact same problem that we did, just in general terms, but we have a shortcut, and I just want to really, really exemplify that one more time. If we look up at the examples from just a moment ago, and I see people still writing, so I'm going to try to pause for just a skosh. You know what? Without writing them down, we're going to do a couple examples. Michael, what's your favorite complex number? 6 plus 7i. Deal. What's its conjugate? 6 minus 7i. Okay. If you can identify the conjugate right off the bat, all you have to do is change the sign. Now, without doing all the foiling, can you tell me the 2 numbers that we have in front of the, with the exception of I, rather? So 6, so what's 6 squared? 36 plus, what's the other number I need to deal with? The b in this case. 7 squared is? We can do these things without doing all the FOIL if and only if we have the conjugate here. So let's see, I think that's 85. And we're done. If you want to distribute it out and FOIL it, is that cool? Yeah, absolutely. If you want to spend 30 seconds each time doing it, you're good too. But there is a handy shortcut if you have the conjugate. Okay. For the remainder of class, I'm going to give you an assignment, and you guys get a little bit of time to work on it with the understanding that I'm so prepared to just start the next part of the section if needed. That's my tip to say do what? Work. Yeah, stay on task with stuff. Okay, I deleted all of our classes and redid them because about half of you guys weren't in there. You might have got a notification. You guys should check out this link this evening as well. I'm going to put that on the homework. Use your school computer. Click that link. It'll re-sync up your stuff with the textbook stuff in hopes that we might be able to do a little bit of online stuff from time to time. Okay, for this evening, and starting right meow. Hey, here it is. Look at that. 2.4.3. Our stuff is all weird and shoved together because of quiz review and stuff. Here's the part that you care about. I want you guys to do homework 2.4.1, which you will find waiting for you on page 88. The asterisks around this mean I want you to try it. Okay, it's might be a challenge. I don't know for sure, but I want you to try this. We have number 10, 12, and 15 through 29 odd. If anybody's been checking, I did this weekend finally get around to uploading the odd answers to the Google Classroom. Sorry it took so long. We're already through 4 sections. That's my bad. I want you guys to work on this now so that if there's issues with the complex stuff, we can deal with it. Cool. All right, you get 12 minutes. You should realistically get a pretty good jump on this and have almost no homework this evening. Cool.